Welcome to another video lesson for statistics and probability. Our topic for today is about identifying regions under normal curve corresponds to different standard normal values. It's me, Juliet G. Bernachea. Our objectives are the following. Number one, identify the regions under the normal curve or different standard normal values. Number two, use the z-table or table of areas under the normal curve to find the regions that correspond to the z-values. And 3. Sketch the normal curve showing the required regions or areas. In the previous module, we discussed the properties of the normal probability distribution. And one of the things that you've learned is that the total area under the curve is equal to 1. Since the standard normal distribution is defined as normally distributed random variable having mean of equal to 0 and standard deviation is equal to 1, the 50% of the region under the curve is below the mean and the 50% is above the mean, as shown in this given figure 1. You can easily identify the area of the regions under the normal curve by using the table of the areas under the normal curve, which is also known as the z-table. This table gives the area of any value of z from negative 3.99 to positive 3.99. The value from this table will describe the area of the specific region of the curve to the left of the given z-value. So in this given z-table, the numbers of the left side of it are what we call the z-values, while the numbers at the upper part of the z-table are what we call the hundreds place of the z-values. How to use the table of areas under the normal curve. So there are 4 steps process in finding the areas under the normal curve given as z value. Step 1. Express the given z-value into a 3-digit form. Step 2. Using the z-table, find the first 2 digits on the left column, are the z-values. Number 3. Match the third digit with the appropriate column on the right side. And number 4. Read the area or probability at the intersection of the row and the column. And this is now the required area. Example number 1. Find the area that corresponds to z equals 1. First and foremost, we have to locate where does the area of z equals 1. So first, in our standard normal curve, we have here that the mean falls exactly at 0. So we will have from this point as its middle, and then 1 is at this point. So what we're asked to find is this given area. So this part. What is the area of this shaded region? Z is equal to 1. For us to find the area of that, we need to use the z-table. First step, express the given z-value into 3-digit form. So its 3-digit form is 1.00. Second, using the z-table, find the first 2 digits on the left column. The first two digit is 1.0. So locating it on the left column of the table, this is the 1.0. And its hundredths digit is 00. So in step 3, match the third digit with the appropriate column at the right. So from this point, 0.00, finding its intersection, we have the 0.3413. Read the area or probability at the intersection of the row and the column. And this is now the required area. The area is 0.3413. Example number 2. Find the area that corresponds to z equals 0.3. Let us first identify the regions of 0.3. So from the middle, from the mean, we'll have this one. And 0.3 is just between 0 and 1 since it is positive. And 0.3 is less than 0.5. So if this is 0.5, 0.3 is at the left side of 0.5. So with that, this is now the region for 0.3. So we are asked to find the area of this given shaded region. And for us to find that, we'll be needing our z-table. First step is to make 0.3 into 3 digit. So this will be 0.30. Second step is to locate the first two digit at the left side of the z-table. The first two digit is 0.3. And the last digit is the hundredth digit. Since it is 0, it falls under 0.00. And then, for the last step, let us now locate their intersection. And it falls under 0.1179. The area is 0.1179. Example number 3. Find the area that corresponds to 1.196. Let us first identify the regions of z equals 1.96 from the middle, from the mean. 1.96, it is positive, so it is at the right side. And that is less than 2. So if this is 2, it is at the left side of 2. Then let us shade the given region. So this is z is equal to 1.96. For us to find the area of 1.96, of course, step 1 is to make it a 3-digit form. It is already in its 3-digit. Second step is to locate the first 2 digits of the given. So 1.9. 1.9 is at this part. And then in its hundredths digit, 0.06. 0.06. So 0.06, such that when we add 1.9 and 0.06, the result is 1.96. So 0.06 is at this part. Then after that, let us locate its intersection. And this is their intersection. The area of Z equals 1.96 is equal to 0.4750. Example number 4. Find the area that corresponds to Z equals negative 1.15. When we say area, it doesn't have a negative value. Area is always positive. So for us to find for the area of negative 1.15, we have to sketch or find the region of negative 1.15. Since it is negative, it's obviously that it is in the left side of the given normal curve. So, since it is negative 1.5, so that is the given region. Since, as I said a while ago, that there is no negative area, finding the area of this region having z is equal to negative 1.15 is the same as when we find the area of positive z value. The difference is that when we have a negative z value, your region is at the left side of the mean. So, let us continue finding its area. Since it is negative 1.5 or 1.15, let us first look for 1.1. And for the hundredths place, we will look for 0.05. So 0.05 is this part. So let us have its intersection. And from 1.1 to this part. So the area of negative 1.15 is 0.3749. Example number 5. Find the area that corresponds to z equals negative 2.18. Again, since it is negative, its shaded region is at the left side of the mean. And since it is, even if it is negative, the value of the area is still positive. So let us sketch the given region of negative 2.18. So this is the mean, and then negative 2.18 is less than 2, so therefore it is at the right side of 2. Okay, here it is. So this is now the shaded region or the region of z equals negative 2.18. For us to find for the area of this region, first, we will have the first two digits. We'll locate the 2.1. 2.1 is this part. And its hundredths place is 0.08. 0.08 is at this part. And then, finding its intersection, and from 2.1 up to 0.08, and here it is. The area is 0.4854. Find the proportion of the area above z equals -1. In this given, we have to use for a certain notation. So we have this table wherein you will encounter terms like greater than z, at least z, more than z, to the right of z, and above z. If these terms are being mentioned in the given, identify first if this is positive or negative. And then, here is the operation. Now, in our given, find the proportion of the area above z. So, it falls under this category. And the given is negative. So, since it is negative, we falls under this one. What we're going to do is to add 0.5 to the corresponding area. So, let's illustrate. Z equals -1 is at the left side of the mean. Since it is stated that above z is equal to -1, therefore, the shaded region is from -1 going to the right side. So, including the other side of the mean. So, what is now the area of the shaded or this region? So, from here, it says here, add 0.5 to the corresponding area. Since we know that from the middle going to the right is 0.5, and the area from the mean going to -1 using the given table is 1.0 and 0.0 is 0.3413. So what we're going to do is to add 0.5 plus 0.3413. 0.5, since you're going to add, let's add up 3 zeros. That's the same. So 0.5,000 plus 0.3413 is 3148. And the area of z equals -1 is equal to 0.8413. What about find the area greater than z equals 1? So let's illustrate. Greater than z equals 1. So it is greater than this one. And the given is positive. So let us illustrate it in the given normal curve. This is the mean. 1 is this one. It says here, find the area greater than 1, meaning the given region is from 1 up to this region. So this is now the region that we're going to find. Since it is positive, the operation says that subtract the area corresponds to the given from 0.5. So we will subtract. Let us first find the area of 1. And 1 is 1.0 and 0.0. And that is 0.3413. says here, subtract the area from 0.5. So therefore, 0.5,000 minus 0.3413. 0.3413 is equal to 0.1587. Subtract the corresponding area from 0.5 and the result is 0.1587. Example number 8. Find the area to the left of z equals negative 1.5. Let's illustrate first so that you have an idea. Again, here's the mean. And negative 1.5 is at this region. The given problem says to the left of negative 1.5. And the left side of negative 1.5 is this region. So, therefore, that shaded region is the area that we're going to find. Since it says here that it's to the left is in this given, and that's negative, to the left, and that's negative. So what we're going to do is subtract the corresponding area from 0.5. So, first, we will find for the area of negative 1.5. So, negative 1.5, we will locate the 1.5. 1.5 is in this part, and its hundreds place since it doesn't have any, meaning that is 0, 0. So, its intersection is 0.4332. So, we will subtract the corresponding area from 0.5. So, 0.5,000 minus 0.4332. And the result is 0.668. Find the area below z equals 1.5. Below z equals 1.5. So let us sketch first. If this is the mean and 1.5 is here, when we say below z equals 1.5, that means that the shaded region is at the left side. So what is now the area of this given region? So it overlaps going to the 0.5 or 50% of the other side of the normal curve and the area of 1.5. So below is under this part. And it is positive. Below is under this part. Since it is positive, what we're going to do is to add the corresponding area to 0.5. So let us first get the probability of 1.5. So let us locate 1.5. And here it is. And then since it is only 1.5, the hundredths place is 0.00. Locating its intersection, it is 0.4332. So since we're going to add 0.5 thousand plus 0.4332. So the total area is 0.9332. Find the area between z equals -2 and z equals -1.5. So in this case, it has another condition. It is the value of the z is between, or the region is between two z values. So it is -2 and -1.5. In short, we will find for the area of this region. So in this case, since it is in between and they have the same sign, what we're going to do is to subtract the smallest area from the biggest area. So first, we will find for the value or the area of z equals -2. And z equals -2 is 2.00. So let us first locate for 2.0, this one, and this one. So its intersection is 0.4772. 0.4772. And then, let us also find for the area of -1.5. -1.5 is this one, and its hundreds place is 0 also. So, 0.4332. 0.4332. Says here that we will just subtract the smallest from the greatest. So, we will subtract these two. Subtracting 0.4332 from 0.4772 will give us 0.0440. Example number 11. Find the area between z equals 0.98 and z equals 2.58. This time, although it is between two values of c, they are the same, they have the same sign. So let us sketch first. 0.98 is at this part, and 2.58 is at this part. So in short, we're going to find for the area of this region. So same process. Since they are both positive, we will just subtract the corresponding areas of these two. Of course, we will find for, still following this part, we will find for the area of z equals 2.58. So let us locate for 2.5. And then, of course, for the hundreds digits, we have 0.08. And its intersection is 0.4951. So 0.4951. And then the area of 0.98. So the first two digit is 0.9. 0.9 is this part. And then the hundreds digit is 0.8 also. So this is the area of 0.98, 0.3365. And since we're going to subtract, Subtracting 0.3365 from 4951 is equal to 0.1586. Example number 12. Find the area between z equals negative 1.32 and z equals 2.37. So this time, the value of the z are unlike signs, or the other one is negative, the other one is positive. So in this case, let us first sketch the given, identify the regions. So negative 1.32 is at this part, and positive 2.37 is at this part. So what we're going to find is this given region. If you can notice, the midpoint is in this given region. So in short, if we're going to identify the midpoint, that's at this point, So in short, we're going to find for the area of negative 1.32, and we're going to find for the area of 2.37, and whatever the value of this region and also of this region, we will just have to add for us to find for the area of the whole shaded region. So let us find. For negative 1.32, let us have 1.3 and 0.02 for the hundreds place. So we have 0.4066. 1.32 is 0.4066, while 2.37 is equal to 2.3 first, 2.3, and then 0.07, this one. So its intersection is this part, 0.4911. Adding these two will give us 0.8977. That ends our lesson for today about identifying regions under the normal curve. It's me, Juliet B. Please like and subscribe my YouTube channel for you to be updated in my upcoming video lesson. Goodbye!